Okay, this video is going to cover negative exponent operations, but before I go over the operations, I need to talk a little bit about negative exponents. So, you may remember from previous video that I did this 2 to the 4th, and I said that's 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16, and then 2 to the 3rd, that's 8, and then 2 to the 2nd, that's 4, and 2 to the 1st, that's going to be equal to the base, and then 2 to the 0 is equal to 1. Anything to the raised to the power 0 is equal to 1. And I said that because what's happening each time, I showed you a pattern. What's happening is you're dividing by 2 each time, which is the base. So if I continued this and I went 2 to the negative 1, do you have any idea what the next number would be? Think about this as your clue. You're taking this, 1, and dividing by the base, which is 2. And what is 1 divided by 2, or half of 1? Hopefully you say it is 1/2. And then if you went 2 to the negative 2, what is half, if you divide it by the base, of a half? It's 1/4. Do you see a pattern here? Look at this. This, and then this. Do you see that? So if I said the next one, 2 to the negative 3, what do you think that would be? Think about it for a second. Use this as your clue. It would be 1/8. Because the rule for exponents says any number, x, raised to a negative exponent is the same thing as 1 over that number to a positive exponent. So you take the whole thing and you just shove it down the denominator, and now the exponent is positive. So for example, if I had 5 to the negative 3, that would be the same thing as 1 over 5 to the 3rd. Now it's positive. And then 1 over 5, let's see, 5 to the 3rd is just 125. It's 5 times 5, which is 25 times another 5. Okay? Now let's do some things with it. Here, I have a statement that says evaluate the exponents to give your answer as a fraction where necessary. What that means is don't leave negative exponents. So if you have a negative exponent, put the whole thing down in the denominator. First one is 5 to the 3rd times 5 to the negative 5th. Remember, for this, you would add the exponents. This is 5 to the negative 2. I don't want that negative exponent, so I put it in the denominator. 1 over 5 to the 2nd, which is 1 over, 25. Cool? The next one, 5 to the 2nd, and that's over 5 to the negative 2nd. So what I would do is subtract the exponents. Now be careful here, because that's minus a negative. Minus a negative, same thing as plus a positive. So I have 5 plus, or 5 to the 2nd plus 2, which is 5 to the 4th, which is 625. Moving on. I have 2 to the 3rd. The whole thing is raised to the negative 2nd. For that, you would multiply your exponents. So I have negative 2. This becomes 2 then to the negative 6th, which is, oh, that's very nice. Thank you. I'll close that. Close. There. Which is 1 over 2 to the 6th, which is 1 over 64. Cool? Cool. Moving on. Here, determine if the following equation is true, justify your answer. So in other words, what they want you to do is figure out what the left side is equal to, figure out what the right side is equal to, and see if they're the same thing. And if they are, then it's true. And when you figured it out, that's justifying it. So what I always do is I start with the easiest side first. And this is the easiest side. 7 to the 1st times 7 to the 12th is 7 to the 13th, because I just add them. On this side, I'm going to do this first. So this has become 7 to the negative 8 over 7 to the 3rd. Now, some of you may realize right now, this is not going to work. But if you don't, that's okay. 7 to the negative 8 minus 3. We want to see if that's equal to 7 to the 13th. This is equal to 7 to the negative 11th, which is not equal to 7 to the 13th. So your answer is no, and there is your justification. Cool? I think so. Last page. These are a little trickier. We have to really kind of think these out. Determine the appropriate exponent to make the equation true. So in other words, now I have these I have these equations here, and I have an unknown. You have to tell me what number would go in there to make sure that this left side is equal to the right. For this, again, I like to start with the right side. I like to start with whatever side has everything given to me already. So this is h to the third times h to the negative fifth. For that, I would just add the exponents. So this is going to be h to the negative second. So I need to figure out on this, or you could say it's 1 over h to the second. But what I need to do is figure out what do I have to do here, math-wise, and then what number has to be in here in order for the whole thing to be equal to a negative 2. So if you think about it, it's a fraction, so that means I'm going to be subtracting the exponents. I have h to the negative second minus some number. Oh, I put a variable in there. Look at that, I put x in. It looks like algebra. So negative 2 minus what number would be equal to a negative 2? That's what you need to think. Now, later on, we could show this as an equation. You could say negative 2 minus x equals negative 2, and you can solve for x. But we're not quite there yet, so don't worry about that. So mentally, what would you subtract from a negative 2 to give you negative 2? And you would say nothing or 0. And that's the truth. So h to the negative 2 minus 0 would make these true, or make these equal. So in this case, x would be equal to 0. You don't have to call it x. I just did that because I like to put a variable in. Try the next one. See if you can do that. It's a little trickier, okay? But it's not that bad. So go ahead, pause the video and try it. Okay, again, I like to start with the right-hand side. I have 6 to the negative 8. 6 to the negative 8. And it's going to be plus 8, which means this whole thing is 6 to the 0. So I need to think what's going on over here, and what number has to be in for that question mark in order to make this, the exponent on this side, 0. Well, I know that these two get multiplied, and whatever I get for that, I'm going to subtract the 6 down in the denominator. So if I want 0, that means that the whole thing in the numerator has to be 6. I'm going to have 2 times what would give me 6, and hopefully you would say, oh, that would be 3. 6 to the second raised to the third over 6 to the sixth. This would be 6 to the sixth over 6 to the sixth. That's supposed to be a 6. This is 6 to the 0, and then it would work. So here, in this case, x, if you want to call it x, would be 3. That is all. Goodbye.